Here is a question number 1 for physics paper on 24th September 2023. The question says that a particle of mass m is tied to a string, light string, and rotated with speed v along a circular path of radius r. If T is tension in the string and mg is gravitational force on the particle, then the actual forces acting on the particle are. So if you observe, the actual forces acting on the particle are, the particle is moving in a circular path. So let's draw a circle, but it is not mentioned whether it is moving in a vertical circle or horizontal circle. So this will see as a circle along circular path of radius r. So the actual forces are mg is in downward direction, which is a real force, and tension in the string is this one, T, and away from the center there is also mv square by r, which is a pseudo force. Okay, so the actual forces are actually mg and T only, but with all, including with mg and T, there is also one more force, which is mv square by r, pseudo force. So that pseudo force does not come under the actual force, it is the additional force. So you have to mark the answer mg and T an actual forces and an additional force of mv square by r directed outwards. So that's the answer for this question. Let's move on to the next question. The second question says that a motor car with a mass m moves with uniform speed on a horizontal level bridge, convex bridge. A is a horizontal level bridge, B is a convex bridge. So we can draw here A. This is A. Let's say this is A. One is the convex bridge, which is this one, and the other is a concave bridge, which is this one. So the reaction of the bridge at its center is more. See, if you observe, if you draw the forces acting on it, so we'll draw the forces acting on it. So one is here. When it is here, the forces acting on it are, take the color, so M, this is a normal force, and this is gravitational force mg, and here you have a block, or you can also take it as a motor car, no problem. When it is moving with velocity v, in additional to this normal force, there is also a force which is acting away from the center, which is like mv square by r. So this is mv square by r. So therefore, if you balance, you have n plus mv square by r is equal to mg. So therefore, you can write n is equal to mg minus mv square by r. So this is the normal force in second case. Similarly, the normal force in third case would be, here is a mass m. When it is moving away from the center, when it is moving with velocity v away from the center, you have mv square by r, and also you have a gravitational force in downward direction mg, and this is the normal force in case of the third bridge, which is C, concave bridge. So therefore here n is equal to mg plus mv square by r. So the answer should be on the reaction of the bridge is highest in which case? It is actually highest in case C, which is option C. Let's move on to question number 3. A stone is suspended by a thread. The minimum horizontal velocity that should be given to the stone at lowest position to complete vertical circle. So we have studied in vertical circular motion that there is a mass which is suspended at vertically, then it has to be given some velocity v0 so that it would complete a complete vertical circle, and that velocity is actually v0 is equal to root 5 gl. So root 5 gl. So if you observe, it depends on length of the thread. Of course, it also depends on the acceleration due to gravity g, and that's it. So the answer for this question is it is independent of the length. No, it does depend on the length. It depends on mass. No, it only depends on the length of the thread. So the option A is correct. So I'll come back to this one. See, first one is option 3, the second one is option 3, and also and third one is option 1. Let's move on to question number 4, and we can do 4 and 5 together here. Moment of inertia of a body depends on. Let's write the formula for moment of inertia of any random a ring or disc you can take. It is mr square for a ring for about natural axis. This is mr square for a ring about natural axis. So if you observe I is equal to mr square, then it depends on mass of the body. So of course this is correct, and distribution of the body is also correct. Temperature of the body is also correct, but it does not depend on the angular velocity, which is omega. So if you observe, there is no omega in the formula. So moment of inertia is independent of omega, which means option 4 is correct. 1, 2 and 3 are correct, but that's not the option for this question. Moment of inertia of ring is minimum about which axis? So we can see the moment of inertia of ring for different situations, different axes. So for a ring, the moment of inertia about natural axis is, I am writing here, is mr square. For natural axis is mr square, and for diametrical axis it is mr square by 2, and for remaining all the other axes it is more than this or more than this. So sorry, mr square by 2 here. Yeah. So for a ring, this is id, diametrical axis, and this is in, natural axis. So if you observe, id plus id is in, so id is in by 2, therefore it is minimum about diametrical axis. So the correct option for question number 5 is option 2. Let us move on to question number 6. A point on the rim of a wheel. Let's draw the wheel first. So here is the wheel. So there is a point on the rim of the wheel. This is rim, rim, rim. So 3 meter in diameter. So diameter is 3. So radius would be 3 by 2 meters. Has a linear velocity. Linear velocity is like tangential to this one, v. So we have v is equal to r omega, which we can write in circular motion. So linear velocity is 18 meter per second, and radius is 3 by 2 into omega. Therefore omega becomes 12 radian per second, which is a very simple question and very easy question. So the answer is 12 radian per second. Option number 2 is correct. Let's move on to the next question, which is question number 7. A coin is kept at a distance of 10 centimeter from the center of a circular turntable. We'll draw the table. So here is a table and a coin which I have drawn. So, and the coefficient of friction is given as mu is equal to 0.8. The frequency of rotation at which the coin just begins to slip. If you observe, the options are in RPM, rotations per minute. So we can convert them into rotations per minute, no problem. So first of all, before doing it, we'll draw the forces acting on this coin, which is you have away from the center mv square by r, or simply you can also write mr omega square. Better we write this one. And the friction is protecting it from not to fall. So we can also balance gravitational force mg and normal force n. So now you can write friction F is equal to mu times normal reaction. So normal reaction is mg in vertical direction if you balance n is equal to mg. And now we'll equate this. Friction is mu into normal reaction. So mu mg must be equal to mr omega square. So let's substitute this. Mu is 0.8. I am writing it as 8 by 10. So you can actually cancel m. G will take it as 10 is equal to r is radius, which is 10 centimeters. So you can witness 10 by 100 into omega square. So this will give you omega square is equal to, okay, let's do one thing. Let's substitute 9.8 G because it's not properly getting cancelled. Or we'll just keep it this way as 10. Let's see what happens. So now this 10 got cancelled, also this 10 got cancelled. Omega square is 80. So when omega square is 80, we can nearly write omega as 9 because 9 is 81. So now you have omega is 2 pi by t. So or you can also write it as 2 pi f, where f for frequency. 1 by t is frequency. Or simply look at this point. Since the answers are given in RPM, which is rotations per minute, so what we can do here is we can convert radian per second into rotations per minute. How do we do that? Look at that. Omega is 9. So omega is 9, which is 9 radians per second. So 9 into 1 radian. See, one rotation is how many radians? One rotation is 2 pi radians, right? So 1 radian can be written as 1 by 2 pi rotation. So this is like 1 by 2 pi. Multiply with 1 by 2 pi. If you multiply 9 with 1 by 2 pi, you are going to get rotations. Divided by 1 minute is 60 seconds. 1 minute is 60 seconds. So 1 second would be 1 by 60. So this will give you 1 by 60. And now this is in minute. So when you multiply with this one, which is 60 into 9 divided by 2 pi, then this is your answer. Now if you calculate this, this is nearly 230, 2 3s 30, 270 by pi. So pi is like 3.14. So approximately you can write as 270 by 3, 8. It has to be this one, 84.54. Yes, that's the answer, I think. And it cannot be any other answer. So the answer is 84.54 rotations per minute. So what you have to simply do is, you got the value of omega, right? Omega is 9 radians per second. So you have to convert radians per second into rotations per minute. How do we do that? One rotation is 2 pi radian. So 1 radian would be 1 rotation by 2 pi. So divided with 2 pi. And 1 minute is 60 seconds. So 1 second would be 1 by 60 minutes. So simply 60 by 2 pi. So, or in other words, you can also remember this as 1 radian, 1 rotation per minute. To convert it into radian per second, we multiply with 2 pi by 60. Here you multiplied with 60 by 2 pi. That's it. So you will get the answer after solving this. Let us move on to the next question. A car is moving in circular horizontal track of radius 10 meters with constant speed. A plumb bob, pendulum bob, is inside the car. So this is a bob, and suspended from the roof of the car. This is the roof of the car. The angle, when car makes a circular turn, a car is here. So this is a car makes a circular turn, then away from the center a force acts, which is mv square by r. And there is also, because of that away from the center, there is nothing to balance here. That's the reason why the bob rises up and the bob will be here. So there is no more bob which is suspended here, which means the bob is acted upon by force mv square by r away from the center, and there is also tension in the string, which is a T. This is a T, tension in the string. So this would be T. This is a T cos theta, vertically upward direction, and this is a T sin theta. And in downward direction there is mg, which this is a very simple and very standard problem. So when you equate this, T sin theta is mv square by r, and t cos theta is mg. So when you divide these two, t gets cancelled, and tan theta is equal to mv square by r by mg, which will give you v square by rg. So if you want theta, then you have to simply calculate v square by rg. So let's do that here. V is the speed with which it is moving, 10 square. So v square by rg, I am doing it here, see. So 10 square divided by r is a 10 and g is also 10. So this is 100, which means this is 1. So when tan theta is 1, it is obvious that the angle is going to be 45 degrees. That's the answer for this question, option C. Now here comes a very good question. A block slides down an inclined plane of inclination 60 degrees with an acceleration g by 2. Find the coefficient of friction. You have to simply see how many forces are acting on it. This is mg sine theta, which is mg sine 60 degrees. And in this direction there is a friction. Here it is. And this is normal force. And this is mg cosine theta. So you know here in this case the friction is mu times normal reaction, which is mu mg cos theta. So the net force in downward direction has to be ma is equal to mg into sine 60, which is root 3 by 2, minus mu into normal reaction, which is mg cos theta, which is mg into cos 60 is 1 by 2. It is given that it will move down with acceleration g by 2. So in place of a, you can write g by 2 and solve this one. So m got cancelled. I am substituting a is equal to g by 2 and doing it here. So g by 2 is equal to g root 3 by 2 minus mu into again g by 2. So also g by 2 gets cancelled. You are left with 1 is equal to root 3 minus mu. Hence mu would become root 3 minus 1. And that's the answer for this question, which is option number 3. It is a very simple question. Now question number 10. Let's see question number 10. A particle describes a horizontal circle in a conical funnel. Let's draw the funnel first. So the funnel is ready. A particle describes a horizontal circle inside a conical funnel. Funnel is like cone, whose inner surface is smooth with a speed of 0.5. What is the height of the plane of the circle from the vertex of the funnel? So we'll also draw this one, which is a line here. So also the line is, the plane base is drawn. So now here is a particle which is at a height of h from the ground, and it is rotating in a circle with a speed. So away from the center there is a mv square by r, and r is the small r, which is radius of the point, not the radius of the funnel. Radius of the funnel is actually bigger than this one. It might be making circle somewhere between this point and this point at some random height h. So now what we'll do is we'll draw the forces acting on it. One is the gravitational force which is acting downwards, which is vertically downwards mg. The other is a normal force which acts perpendicular to the surface here. So if you observe, this angle is theta, so this is 90 minus theta. Therefore this would be theta. So hence it becomes n cos theta, which is balancing mv square by r, and this is n sin theta. So you can write here, I am doing it, n sin theta is equal to mg, and n cos theta is equal to mv square upon small r. So if you divide these two, sin by cos is a tan theta is equal to rg upon v square. But if you also observe in this triangle, tan theta is again opposite by adjacent, which is small r by h. So in place of tan theta you can write small r upon h, is equal to Rg by V square. We also have discussed this in class. R got cancelled. Then H is equal to uh, V square by G, or simply V equal to root GH. So you want V square by G, so 0.5 square divided by G is a 10. So 0.5 square is 0.25 by 10 meters, and we also know 1 meter is 100 centimeters, so multiply with 100. Then you have 25 by 10, which is simply 2.5 centimeter. So that's the answer, which is option number 4 for this question. Let's solve question number 11. This is a bit interesting question. A block of mass m is lying on a verge having inclination theta alpha equal to tan alpha is given as 1 by 5. So when tan alpha is 1 by 5, we can write remaining all trigonometric identities. So when tan alpha is 1 by 5, sin alpha would become 1 by root of 26, and cos alpha would become 5 by root of 26. I am hoping you understood this step. It's not a tough step actually. We have constructing a small triangle where we are making it as alpha. Tan alpha is 1 upon 5, so this is 1 5. This has to be root of 5 square plus 1 square, which is 26. So that's it. So a block of mass m is lying on a wedge having inclination alpha equal to tan inverse of 1 by 5. Wedge is moving with constant acceleration. The minimum value of coefficient of friction so that m remains stationary with the wedges. So you have to understand that when this m is remaining stationary, all the forces acting on it are 0, right? So this is m a naught, which is pseudo force, which is m into 2. And also you have frictional force this way, n. This is frictional force F. And this is normal force. This is mg cos theta, and this is mg sin theta, and that's it. The minimum value of coefficient of friction is asked. So you must know that if this angle is alpha, then also this angle is alpha, then this is 90 minus alpha. So this is alpha again. So I hope this is clear. Look at this one. This is alpha. So the angle made by the horizontal with this plane is alpha. So since these two are perpendicular, normal and this plane, this is 90 minus alpha. This part is 90 minus alpha. Okay. So this is alpha. So it becomes, let's do it this way. Otherwise, we can make components of this m into 2. So I'm drawing the free body diagram actually. See. So here is a diagram. Let me mark the forces here. So this is m a naught, which is m into 2. This is alpha. So this would become m into 2 cos alpha, and this would become m into 2 sin alpha. M A naught, pseudo force. And this is a normal reaction, and this is mg cos theta, and this is friction F. First of all, we will find out the friction, we'll find out the normal force by equating vertical equilibrium. So you have n plus 2m sin alpha, which is 1 by root 26, is equal to mg cos alpha, which is 5 by root 26. Now the value of n would become m into g into 5 by root 26 minus 2m by root 26. This is the value of n. Now friction, coefficient of friction is this one, friction is this one, and this is 2m cos alpha. Also in equilibrium they are equal, so you can write F is equal to 2m into cos alpha, which is 5 by root 26. And also friction is mu times normal reaction. So friction is mu into, if you observe what is the normal reaction here, mg into 5 by root 26 minus 2m upon root 26 is equal to friction, which is 2m into 5 by root 26. You can cancel m and also root 26, then you are left with 5g minus 2 is equal to 5 to 10. So let's take g is equal to 10, then you have mu is equal to 10 upon 50 minus 2 is 48. So we can write this as 2 5s 10 to 24s, 5 by 24. But there is no 5 by 24 here. Oh yeah, actually I forgot this one, mg sin theta here, so that's why I got this one. I didn't write mg sin theta. So mg into sin theta is sin alpha, which is 1 by root 26. I actually forgot this one. Oh yeah. So now this would be, friction has to be equal to 2m into cos alpha plus this one mg, plus mg into 1 by root 26. And now I think I'll get it. So I simply have to add mg by root 26 here. Then I think I'll get, when you cancel m by root 26, you can just check it. I'm doing it perfectly here. M by root 26 got cancelled. So 2 5 is 10 and g is also again 10. So that means here I'll get 20. Okay. Yeah, we got it. So 20 upon 48. So this is 4 5s 20, 4 12s 48. So the answer is 5 by 12, which is option 2. I forgot to take this mg sin theta. Kindly reconsider it. And here is a very good question. A particle is projected with a speed of root gr, the coefficient of friction. So here is a circular path, and here this is the point from where it is projected with v0. The coefficient of friction between the planes is 0.5. Then the acceleration of the particle is. So how to find out the acceleration of the particle? Let's see. First we will draw the number of forces acting on it. One is the gravitational force mg acting downwards. Also away from the center, mv square by r, which is m v0 square by r, but v0 is given as root gr, so you can write it as m into gr upon r. This will give you mg again. So that means in downward direction, one is mg due to this rotation effect and also the other mg. And there is also normal force acting here, N, and there is also frictional force acting here, which is this one. F is mu into normal reaction. So frictional force is F is equal to mu into, if you do the equilibrium along vertical, you have N is equal to mg plus mg, which is 2 mg, correct? 2 mg. So F is equal to mu into normal reaction. So mu into normal reaction is 2 mg. So therefore the friction is mu times, which is 0.5 mentioned here, into 2 into mg, which will give you friction is also mg. Now the acceleration. You must know that for any particle which is moving in circular path, there are two accelerations. One is centripetal acceleration, the other is tangential acceleration. So now this is moving in a circular path like this. Okay. Centripetal acceleration is, v square by r towards the center, which is v square upon r towards the center. And what is that? V or v naught square by r, which is if you do v naught square, then gr upon r is g, and the other is tangential acceleration, which is this way. If you observe, friction is present here. This is actually giving you the tangential force, tangential retardation. That's the reason why it is slowing down in this direction. This is the direction of velocity v naught, but tangential force is this one, which is frictional force, which is also mg. And the tangential acceleration would be, you can write mat is equal to mg, then the tangential acceleration is g. Now you have two accelerations. One is centripetal acceleration for any particle moving in circle. Centripetal acceleration is v square by r, which is g, and the other is tangential acceleration, which is again g. And the resultant of these two is root over g square plus g square, which is root 2g. And this is the answer, option number 3 for question number 12. Let's move on to question number 13. During inelastic collision between two bodies, inelastic collision, which of the following quantities always remain conserved? In any collision, the total linear momentum is going to remain conserved. Speed is not going to remain conserved. Total mechanical energy is also not constant because energy is lost. So therefore, only option 3 is correct for this one. And now question number 14. The centripetal force required by a 1000 kg cart that takes a turn of radius 50 meter at a speed of 36 kmph, 36 into 5 by 18, convert into meter per second, 10 meter per second. So now you got this into this one. So the centripetal force is simply mv square by r. So m is 1000 into v square is 100 by r is 50. So this will give you 52. So 2000 Newton must be the answer. This is a pretty simple, straightforward question. And now is this the last question of first part of the solutions of paper. A stone of mass 0.5 kg is attached. I will do the remaining solutions in the next part. Attached to a string of length 2 meters and whirled in horizontal circle. So this is horizontal circle. Okay. I have already drawn the circle here. A stone of mass 0.5 kg is attached to a string of length 2 meters. L is 2 meters, which is our radius here. If the string can withstand the tension of 9, so if the tension is beyond 9, then it will break. So that means the value of mv square by r must be less than tension. So, or at least equal to. So the maximum velocity must be v square must be less than or equal to rt by m, or v must be less than or equal to root rt by m. So we'll find out this root rt by m. So root of r is length, which is 2 meters, tension is 9, and mass is 1 by 2. So this is 9 fourths, 36. Root 36 is 6 meter per second. So if the speed exceeds 6 meter per second, then the string is going to break. That's the answer for this question. So the remaining questions will be solved in part 2.